Okay, this lesson is lesson number 5, and it says changes over rational interval. Now, what is rational intervals means? Not changes from 1 to 2 or 2 to 3. It could be fraction 2.5 to 3.5, like from fraction, right? So that's the goal of the lesson. If you see this in the green, let's look at how functional changes when the input changes by a fraction amount. And at the end of the lesson, our goal is uh, success criteria is I can explain why an exponential function changes by the same factor over equal intervals when those intervals are not whole numbers. So this is what our goal is to see with these three activities that we are going to work on. So the first one is, here it is. First activity is 5.1. Consider, so they gave you the function hx, here it is. Clearly, can you see this part? Can you underline, put a box around it? So hx is given to you as f4 raised to the power x. For each question, be prepared to share your reasoning with the class. So the question is, by what factor? Now, factor means what number multiplies. When you write 6, 6 is 2 times 3. Okay, so that means 2 is a factor, 3 also is a factor. So here the question is, where is that? By what factor does h, it means the output, we want to know the output of this h of x when the exponent x increases by 1. Let's see. So first one is saying if x increases by 1, so we'll write this part here. So hx is, hx is 4 raised to x. All you do is, in place of x, you replace it by plus 1. So it is increased by 1. So x is replaced by x plus 1. So this will be h of x plus 1 equals 4 raised to x plus 1. So you replace x by, so this x is replaced, right? And then by power of laws of exponent, that if we have a raised to m plus n, we can always write it as a raised to m times a raised to n. So this could be written as 4 raised to x times 4 raised to 1. So look at this. This is equals, I'm going to write 4 raised to 1 first and then write 4 raised to x. See? So it means the 4 raised to x is what was the original function is. So this is the original function, which is 4 raised to 1 times h of x. So we began with, so what is the conclusion is, we begin with h of x plus 1 and we ended with this. So if this is 1, so look at the color that I put here. So if it is plus 1 here, so if this is plus 1, okay, then this is 4 raised to 1. So that's the factors. This is 4 raised to 1, which multiplies the original function. And that's why this is a by what factor. So the factor is 4 raised to 1. Did you guys get this so far? I want you to focus on the color that I use, that is that plus 1, x plus 1. That plus 1 is important. So this plus 1 is raised to 1 here. So whatever that 1 is, it is raised to 1. Let's do the second one. Okay, the second question is, by what factor does h increase when the exponent x increases by 2? So that means in place of x, you replace it by x plus 2. Okay, so that means h of x was given to us as 4 raised to x. So in place of x, you're replacing it by x plus 2. So this becomes 4 raised to x plus 2. See, so x is replaced by, is that correct? And then we can separate this. So how do we separate this is we can write this as 4 raised to x times 4 raised to 2. Okay, so that means so this is h of x plus 2, but then we can always write this as 4 raised to 2, 4 raised to 2 times 4 raised to x. But then 4 raised to x is, so this is 4 squared times h of x. So what is the conclusion? So we started with h of x plus 2, and then we ended getting 4 raised to, so let me show. So we ended up getting this important, look at the color that I put. So if there is a plus 2 here, so if there is a plus 2 here, then you put 4 raised to 2. So that's important. So the goal is, can we understand this, where this came from? So this piece is very important, which is the factor. So the original factor, that here it is, 4 raised to 2. So this is it. So this was the original output. This is the main one, but it gets multiplied by 4 square. That is the factor. That's why it is called a factor. Okay. So this is like times. So of course, it is 16 times. Actually, the answer is going to be here 16 times whatever the output, the original one. So it depends on which one are you talking about. Then next is the last one. By what factor does the h increase when the exponent is increased by 0.5? Now that's the fraction. See, this is the fraction part. So again, let's write the step. So that's why I want you to write the steps. Is h of x is 4 raised to x. This is the given one, right? Now you're replacing x by x plus 0.5. So it means h of x plus 0.5 equals 4 raised to x plus 0.5. I'll put this in the parenthesis just to show that it is in the exponent. And then you separate this, that is 4 raised to x times 4 raised to 0.5. Now this can be written as 4 raised to 0.5 because it's a number, that's a factor, and times the 4 raised to x, 4 raised to x. And this is same as 4 raised to 0.5 times hx, the original function. So what did we learn from here is, this is what we started and this is what we got. Look, so that's how beautiful this is, that whatever the beginning, if whatever you're adding here, so this plus 0.5 that is added up, the fraction input is increased by something, then the final answer is 4 raised to 0.5, whatever that is. So where did this 4 come from? It is because the original function has the base is the 4, that because this is the growth factor that is here. So this growth factor gets multiplied. Okay, I hope this helped. Let's go to the next one. So even though I took a little more whole understanding of each one of this, that you have understood. Okay, the second question is, this is about machine depreciation. So when you buy something, the value of the machine depreciates by some percentage from the time you buy, and every year it depreciates. The value of the machine goes down. And you know exactly, like even when you buy a car, the value of the car goes down every year. Okay, so this is about any machine. The purchase, after purchase, the value of machine depreciated exponentially. The table shows value of the function f since the purchase. So whatever the column, first column is from the time you purchase, and the second column is the value. If a spreadsheet tool is available, you can use it. Of course, you can show this using your spreadsheet, but we will do directly here. So this is the table. We'll try to fill this up. So there are one question. So there is two and three has A, B. So there are four questions here. Let's do one at a time and understand this. Okay. So the first question is, okay, let's analyze this. Year since in the beginning it was $16,000. Okay. So that's 16,000 when you bought the car. I mean machine. Then there's a blank. Half a year, nothing. It's just a blank. Okay. But they gave you after 1 year, the value of the machine is 13,600. Then again blank, and then after 2 years, it is 11,560. Correct? So they gave us at least 0, 1, 2, and 3. So the increase of each year is given. So every 1 year, how much? So we need to now see the value of the machine in dollars is a function f of time. It means the value of the machine depends on how many years pass by since the purchase. So the first question is find an equation defining f. So can we create an exponential function? Can we model an exponential function for this situation? Be prepared to explanation. So let's do that as the first part, and here it is. The first question is, so all we need to know is, okay, so look here. So this one, we need to know, when we talk about exponential function, I want you to write this. Y is A times B raised to A. This is our main exponential function. So what it means is, this is for x equals 0, 1, 2, like. So now this B is for x equals 0, 1, 2, 3. So that means B is exponential growth, and A is when it was in the beginning, when x is 0, that's the beginning or the y-intercept. Now in this example, if you see, in the beginning, this becomes the A. See, this part is the A. Can you take a note of that? A means whatever the beginning. So when we want to create exponential function, let's see how, if I want to write f of t, so let's write here f of t is number of years. So f stands for the value of the, so let's see, this is t and this is f of t. So far so good. So ft is, so the beginning is a, so that is, it's like a times b raised to t, like something like this. But then we need to know what is that a, right? A is, in the beginning it is 16,000, so it is 16,000 times, and then now remember the b is, this b is growth factor in the increment of 1, 0 to 1, 1 to 2, like that, not the fraction. So that means from 0 to 1, you can see this grows. This is for t equals 0, and this is t equals 1. And you can see from here, so what is that? How did it increase from 16? It means, what is that? 16 times multiplied by what? What gives you 13,600? So this is the question that we need to know. And for this, if you don't know, the only way we do is using the calculator. So, but before that, in order to figure out this b, whatever that b is, we need to know what multiplies here. So what multiplies to get to? So if I ask you a question, what multiplies to get to 6? And we use our common sense, and the answer is 2 times 3 is 6. Okay, but is there another way to do this? So because this is our common sense tells us 2 times 3 is 6. But another way to figure out is just divide this 6 divide by 2. So that way you can get whatever the box, it was a question mark here. Okay. So that question mark becomes 6 divided by 2, which is 3. Now, why I give this example is, can we apply it here now? This is the B, right? So we want to know this B. So B equals 13,600 divided by 16,000, and we can use calculator. Everybody take out your phone and do your simple math there, or you can use our calculator also. So this will be equals, using the calculator. Misael, can you help me? What do you get for the calculator? So do you get, when you, somebody help me, 13,600 divided by 16,000? Yeah, 0.85. So that's the decay factor. This is not a decay, this is not growth factor because the numbers they go decreasing, right? Remember, this is, which is actually 85%. It is 85 divided by 100, which is 85% value. 85% of the value stays. What does this mean? 85% of the value retains. Retains means also stays. So far, so good. That means what do you lose here is you're losing, so you're losing 100% minus 85 is 15% of the value of the machine depreciation. Got it? So you lose 15%, but there is at least, so what we'll do is this is 0.85. So that's important, sir. Correct? 0.85. Makes sense? And we can also check what about from here to here. Let's do this also and really see what about, okay, that we'll see according to the question. If you see the next question is asked, what is the next question there? So, oh, so our question was, the first question was this, right? So now that we know B is 0.85 and this raised to t. So that takes care of the very first question. Got it? So this is like modeling the real situation, real scenario into mathematical model. Okay? So creating a exponential function. So that takes care of the first question. Now, next question is find the value of the machine when t is 0.5. So now what we do, 0.5. So now we have to figure out, hey, what's this? So what's this? So when t is 0.5, so in the equation that we have, so let me wipe this off. Now I don't need this. So this I'll take this. So make a room for me. So you have to do, so substitute, because you need to know for 0.5. Okay. So let's do. So question number 2 is, I think it is question number 2, is asking is, what about when t is 0.5? What is the value of the, that's like a half year, right? Or, and also when it is 1.5. So there are two questions. So that means f of 0.5 is, so it, the thing here, the box shows the thing. So we'll write 16,000. So it is 16,000 multiplied by the red color 0.85. So this is 0.85 and raised to the power, we'll put the this 0.5. 0.5. Now on your calculator, put this and what do you get? Can somebody help me? What do you get? Demarco, can you plug in the values and see what you get here? 16,000 times 0.85 raised to the power. Somebody? Valeria, what did you get? Okay, I'll put it as 14,751.27. I'll write it exactly so that we know. And the second time, so this is for the first part, right? Then the second time you plug in f of 1.5 equals, so that is 16,000 is what the cost of the machine in the beginning. Then the decay factor is 0. I'll use the red color to show that 0.85 raised to the power. This time you're plugging in the black 1.5, right? I don't have enough room here, but I'll write 1.5. So you have to do one more calculation there. And this time, Aiden, can you help me with your calculator? So this is 12,538 point what? Yeah, 58. So I'll put them in the box there. So the first one is 14,000. These numbers are very important. 51.27. And the next one is 12,000. Okay, so we have already filled up. So we finished second question and we recorded that in the table. Now from the table, the question number 3 is asking, by what factor did the value of the machine change every 1 year from 1 to 2? So they're asking is, what about from 1 to 2? So this is the question. So third one from 1 to 3. So 1 to 2. So this they want to know. And also from 0.5 to 1.5. So this is the first question. Okay. So there are two parts here, A and B. So this is A part, and then we have three. We have another question, 3B, from 0 to 0.5, and you also have to have from 1.5. These are the question to 2. Let's see what's happening, right? So by what factor? So if it is 1 to 2, so if it is 1 to 2, and you can see the numbers, important numbers are, I'll use the red color. This is the red. So this is for 2 after 2 years, and this is for 1 year. All you do is, by what factor means what multiplies here to get to this. See the red color? And to do this, how do you find that? So you have to divide 11,560 divide by 13,600. So can you use the calculator and check what you get? See how beautiful this is. From 1 to 2, so you're just dividing those. So the question is, we want to know what multiple. Of course, your common sense from past knowledge, we already know the answer. We want to make sure it is really correct, because from 0 to 1, we already know it is 0.85. And because it is an exponential decay, it has to be the same. Do you get 0.85? Yes or no? Did you get that? No, Isaac? You got it? So when you divide this 11,560 and by 13,000, you get 0.5. And the second time, this means 0.5 to 1.5. It means I'm using black color here. So from here to here is so here it is. So this is 0.85. We also want to know what multiplies from here to get to here. 1.5 to, sorry, 0.5 to, not here. It is asking us from 0.5. Let me take this out. So 0.5 to here. So this is the question, correct? So if it is 0.5, so this time, what are we dividing now? So 1.5, 1.5, 1.5, it is 12,000. So it is 12,538.58. So this divide by 14,751.27. What do you get here? So look at the red color we divided and we got the first one. So this was for the red one we did. And now we want to know the blue one from 0.5. So this one. So all you do is divide this. What answer do you get there? Again 0.85. So what is that conclusion? What do we conclude from here? Oh, I made a mistake. The conclusion is if the input increases by one, okay, what this means is what did we learn here is if the input increases by one, see from one to two, so from one to two, the input increased by plus one, right? And from 0.5 to 1.5 also is increased by plus one. So it's like 1 year. So if it is one, if the input increases by 1 year, the growth factor is 0.85. Is this okay? Nobody saying yes? Correct. So that's the understand. This is important. So if it is one, and that's what we have also in the functions. This now let's see what about the growth factor for not growth, decay factor, because the value of the machine is going down. Now 0.85. So let me clean this also. Let me wipe this because that's too much of stuff I've written down. So let me clean this all and get to the main point. So this I don't need now. Okay. So let's the next is asking you from 0 to zero point 0.5. So this piece, see. So if that is like a half a year, so what this? So what it multiplies? What's the decay factor right there? So if it is to find the decay factor for the half a year, so you'll have to do 14,751.27 and now divide by 16,000. What do you get? So using this, if you do this, 14,700. Can somebody help me? What do you get? So this decay factor, so that let's call this a uppercase B. Now remember, this is the lowercase b in the regular exponential function. We use b as the lowercase b. Okay, but for every half year we can use. So anybody calculated? So the numbers decrease by what did you say? 0.92. Let me use the color for that. 0.92. Okay. So that means this goes when when you think of this factor, it looks like 92% stays. That's what it means, and that means you lose 8%. So if it is just half a year, the percentage losing is less. That's what that means. Now let's do the second part. What about this one for 1.5 to 2 years? See, and I'm going to use other color. So 1.5 to this piece. This also goes by zero point 0.5 increase. See, this also goes. So we want to know whether it's the same thing. Okay. Now the population here is 11,000. So we have to do 11,560 and divide by the population here is 12,000. Put this on the calculator and what do you get? Do you get the same answer? Yes or no? 0.92. Do you see this answer and this answer is the same thing? Yes or no? So what we learn from here is if you are thinking of half year, then the decay factor is they have the same decay factor, like 92% retaining. Uh, so that means this is the B. See, they have the same answers. So that's the understanding, beautiful understanding of the point going half a year. Now let's go to the another question is asking us is last question number 4. So I'm gonna write here just this also goes by from 1.5 to 2. Okay, let me wipe this off because we already know the answer. So now that I know this is 0.92. So this is times 0.92. Okay, but from here to here, watch this. What's the fun? Uh, this from here to here, watch. This is 0.85. Look at that beautiful thing happening. And then again from here to here is 0.85. So it depends on what decay factor is it for what input. Is it every one year or is it half year? So it depends on the situation. Let's see the next question is asking us. Okay, and the next question is saying, suppose we know FQ, the value of the machine, Q years since purchase. Explain how could we use FQ to find F of Q plus 0.5, the value of the machine, half year after that. So let's see. So this is last question number 4. So it tells you FQ. So F of Q, let's see, Q is whatever the number of years. So it was 16,000 times the original function was 0.85 raised to the power Q. Now Q could be 1, 2, 3 like this, any number of years. Okay. And we want to see what's happening now. And then the question is, explain how could you use FQ to find f of q plus 0.5. Let's see. Now what is f of q plus 0.5? Okay. So you're replacing q by, so we are replacing 16,000 here times 0.85, and this q is now no more q, it is q plus 0.85. Sorry, 0.5. 0.5. And like a warm up that we did, we can split this into, so this equals 16,000 times 0.85 raised to the power q times 0.85 raised to the power 0.5. So what did I do here is, if we have a raised to m plus n, this is a raised to m times a raised to n. So I use this power product of power rule here to undo the, of course, the right one is a raised to m, a raised to n is a raised to m plus n. So I'm going backwards, undo the power rule. Then I can write this piece, this whole thing, this piece I can write in the beginning, that is 0.85 raised to the power 0.5 times 16,000 times 0.85 raised to q. So I use the commutative property. We can always swap the order of product. A times B is B times A. And then suddenly you realize that we started with f of q plus 0.5. And then there is a red color. There's a red color factor 0.85, whatever the decay factor, and raised to the power 0.5 multiply by multiply by multiply by. So this is the same. This piece is the same piece as right here. Look at this, which is this piece. See, so it is FQ. So this is FQ. You see that? So basically, what this is a kind of a new rule now. So at any moment, let's see if there was the question was just an example to make you sense. Suppose there, suppose you knew f of 8 years. Let's see if you knew 4 years. If you knew 4 years, okay, then can we find 4.25? Let's see. I don't have enough. Okay, what I'm trying to say is if f of 4, you knew the value of f of 4. Just I'm just saying f of 4. So question is, can we find f of 4.25? All you do is it's just multiply. So this is like a formula. The growth factor, decay factor for every year is 0.85. So the answer becomes, can you write this question? So let's understand this. This is the beautiful thing about math is like this. It means here, if I want to know what is f of 4.25, now f of 4.25 you can write as f of 4 plus 0.25. So basically it's like this is that h, uh, q. This is like a q here, okay? And this is that little increment to the 4, that is little input increases by some fraction. So your answer can be written as whatever the decay factor that you knew before, which is 0.85, and you raise to this 0.25 and multiply to f of 4 like this. See? So it's just you have to just raise it to the power whatever this piece is, you raise it to the x to the base 0.85 and times what you knew before f of 4. Make sense? Okay. Uh, I just wanted to show. What about if I had to ask you? I don't have enough room here. Okay, let's when I go this side. Okay, let's put it like this. Let's put it like this. If I write f of 9 plus. Okay, sorry. If I write f of 9.75, and let's imagine f of 9 is, f of 9 is, I don't know. Of course, let's put it just an example. Is 2,350. Okay, I'm just making my own kind of. So the cost, the value of the machine after 9 years is 2,350. Can you figure out what will be the 9.75? That's the question. So all you do what's the trick? Write this as f of 9 plus. See, you write like this, and then you say, okay, the every increment of 1 year, the decay factor was 0.85. That was the, and you raise it to the this piece, the fraction part, the fraction input, which is 0.75, and then you multiply by f of q. Okay, so this you already know. So that means 0.85 raised to 0.75 times the 2350, whatever that is, 2350. Put on the calculator and you can get the answer. Got it? Okay. I think so. What does this show is The graph shows the amount of medicine in child's body 8 hours after taking the medicine. The amount of medicine decays exponentially. So the graph is showing, so this is the x-axis stands for how many hours passed, and the y-axis is how much, what is the amount of medicine that stays in the body or the bloodstream. Now, if you look at this, let's put this, this is the x-axis, this is 1. So this is the main one, and then where is 2? So if it's 2 will be somewhere here. Look at this. I want you to mark this. So that's 2. They also gave you half hour, and in between also there's a 1/4 of an hour. So that is 1/4. So this will be 3/4. Okay. So 1/4. Then this is actually this 2/4, which is becomes half, and this is 4/4. Okay. So this is 5/4, which is actually 1/4, right? Which is also 5/4. This is 6/4, and this is 7/4, which is also, so this is 7/4 basically means 1/3/4. See, so that's just to get an feel of what is the meaning of 1/4. Then half means 2/4, then 3/4, then 4/4 is 1 because 4/4 is 1, right? Like 15 minutes kind of thing. Now, the question is, let me read the question. So, hopefully, so after 1/4, that means after 15 minutes of this, so this number that you have A, this is, I'll put this as A here. This A is 1/4 is 7 milligram of medicine stays in the blood. So that's what that is, okay? So let's see, put a color for this. So this basically means like, so that's what this means. This is that 7. This is 7 here. Then also it tells after 3/4. That means after 3/4. That means almost 45 minutes. How much is the medicine stays in the body? Is this piece is says 3.5. So this is 3/4, and this is so 3.5 stays. What happened here? So so the question is, so by now, what happened here is, I want you to take a note here, make a table here to understand this. Let's make a table here this way, so we know what's happening. We don't know in the beginning how much was the medicine. This is like a T year, and this is maybe hours H, and this is the medicine M of H after. But they did give us 1/4, then half, 3/4, 1. See, correct. So after 1/4, it was 7, right? Nobody saying yes. And then after 3/4 of an hour, it is 3.5. Can you? Do we even need calculator to figure out what is the decay factor here for that period from 1/4 to 3/4? How many hours passed? Like, let's see. What's the fun? This is so beautiful, actually. If you can understand this, really good. So from here to here, how many minutes? What's the time period from 1/4 to 3/4? What is h equals here? From 1/4 to 3/4 is how many hours? Half hour, right? So I'll put half hour, right? For every half hour, the red color is the factor. How much, what's the decay factor here? Half, right? That's the beautiful part. So it's because if you don't know, let's see if there were numbers difficult. If the numbers were difficult, what would you do? You will do 3.5 divide by on the calculator. This is what you do, and you get half. Of course, you'll be getting 0.5. So the main thing is this is 0.5. Is that okay? So it goes by 0.5. But the question is, if about how many milligram of medicine are left after 1/3/4? Explain it. So 1/3/4, where is one? So here there is 1/3/4 is right here. How much medicine do you think stays here? 1/3/4 here. So the question is, what is this? By knowing this piece, can you figure out that piece? So every time, every half an hour, it is 0.5, right? So how many half an hours are there from here to here? From here to here, how many half an hours are there? So we know from here to here is half hour, right? But we want to know the answer at, this is the question, 1/3/4. So here, 1/3/4, how much is the medicine stays here? I'll use the black color, okay, no, red color here. So, how many half hours are there from here? One half, this is another half hour, yes or no? And this is another half hour, correct? Can you see two more half hours? Do you see that? So, so that means to know that pink color, there is also here one half hour here. So that means you are multiplying by 0.5, and then you have to multiply one more 0.5. Do you see this? So, but then this you already know this piece. This is 0.5. So knowing 3/4, how many milligrams do you want to explain? How do you know? So here it is the 3/4 is the starting. So the m of, let's put m of 1/3/4. Can you write down? So the amount of medicine in the body after 1/3/4 is the same as the amount of medicine at 3/4, because this is what you already know, which is 3.5, and then multiply by the decay factor that you already seen was 0.5. Okay, that's 0.5. That's what we got. See, this is 0.5. So this is the black color. So this 0.5 you raise to the power, and there are two of them. So two red ones, two red ones. So two of this. Okay. So one and two. That's what we did in the, yeah. Okay. So we're almost there. Which is same as, so this is same as m/3/4 is given to you, which you already know, it is 3.5 times, and the rest is just putting on the calculator, 0.5 raised to 2. You can also write it like 3.5 divided by 16 also, which is, if you put on the calculator, you get 0.9. So that's the how much is the medicine stays after 1 3/4 of an hour. So you get this? No, okay, the last question is asking us, I'm going to read this. How does the decay factor, so let's take this off, and let's do this to make a room here. There's too much stuff here. How does the decay factor from 1/4 to 1/2. So what do you think must be happening here? This to this, uh, this number, whatever this, I don't know what is this yet. So I'll call it like, let's say this is B, uppercase, for every quarter. And also, how do you compare this decay rate, decay factor to half hour to from here to 3/4? So this part, so both are quarter of an hour. It's like 15 minutes. So if it is 15 minutes, they will have the duration is the same. See this from here to here is 1/4 of an hour. This to this also is 1/4 of an hour. So because the it is one fraction is the same, the decay factor also will be same B. So you have all you write, you say this, the decay factor for both will be the same thing because this duration is same. That's why it is the same. But if you want to really figure out, they didn't ask us to figure out. Let's do that also. So question is, can we figure out that what is that uppercase B in this case? And it is, and you can see uh from here to here, watch this. From here to here, see, this is the lowercase b, which is a half, which is 0.5. So it goes by half, right? Now the two big b's, so that means the big b's, so the b times b, which because we don't know what is this b and we don't know what is this b, so you multiply itself, and that is the pink color 0.5, which is 0.5. So that means we can write this as b square is 0.5 and b becomes equals square root of 0.5, okay, which is also as 0.5 raised to half, which is also same as half raised to half. See how beautiful this is. So that's the, and if you want to know also how much every 15 minutes, what percentage goes down, we can put this on the calculator. And I want somebody to figure out, if you put this on the calculator, what do you get? Uh, half raised to 1/4. Sorry, half raised to half. Misail, can you calculate this? I want you to do 0.5 raised to 0.5. What do you have? Because it is half raised to half. Same thing it is. 0.701. No, just give me 4 digits. 0.70. Okay, I think this is enough. So what this basically means is, it means if I can change it to the percentage, which is 70.1 divided by 100, which is 70% of the medicine stays every minute. What does this mean? So it means 70.1% of the medicine stays or retains in the body, in the blood, uh, every every 15 minutes or quarter of 1/4 of hour, which is actually 15 minutes. That's it. Okay, so this was the thing. Even I took it long time, but at least many of you will get some idea what's happening is how do we go about doing this. So, hopefully you can complete this. I want you to